Okay. Oh, there I start saying okay again. Apologies. What I'm going to do here is give the official definition of a limit. It's on page 597. You don't need to know this for the exams. I'm giving you this for enrichment, meaning I hope it helps you understand what a limit is. It's a difficult definition, so if you don't get it the first time you see it in this class, hopefully when you see it in another class, it'll be easier to understand. So here it is. I'll give you the definition. Is given a sequence an, the limit equals L if for all epsilon greater than 0, epsilon's a very small number usually, there is an n, an index n, a capital N, such that if little n is greater than capital N, let me make that clear, that's a capital N, the same as this, then an minus L is less than epsilon. Okay, so what does that mean? Well, what I'm going to do is give you the intuitive definition of a limit and show you how that leads to this. So here's the limit. What we mean, this is equal to L if eventually the difference between an and L is very small. So we have, that's one thing eventually. The second thing is the difference between an, and the third is very small. So very small means a positive number close to 0. And what we mean by that, i.e. epsilon. So this is going to be a small positive number. So the epsilon means a very small number, very small positive number close to 0. That's what very small means. The difference between an and L, well, that is an minus L. So if we subtract an from L, or L from an, no matter how we do it, it's going to be a very small positive number. So they're going to be very close. And eventually, that's going to mean all an past a certain point in the sequence. So first, we're going to say let epsilon be greater than 0. That gives us our very small number. So that's a very small. Okay. Lim an minus equals L if eventually if there's an n such that n greater than n, so all an past a certain point, we're saying i.e. an, where n is greater than n, the difference between an and L is very small. So the way to read this is let epsilon be a very small number. The limit of an equals L if there's a capital N such that whenever our index is greater than that capital N, in other words, we have this in where n is greater than n, then the difference between an minus L is less than epsilon. Okay. It's a hard definition to get. I'm going to try to illustrate it with an example, and here we go. Okay. So I'm going to try to illustrate this definition with this example. We know this limit, so it's 2 over n cubed. That's going to be equal to 0. So the way you start out is you let epsilon be a very small number. So I'm going to let epsilon equals 1 over 10 to the 6, my favorite very small number, which is 0.1234556. Okay, I need to find this capital N where this is true. So I'm going to say, okay, I'm going to solve an minus L less than 1 over 10 to the 6. Well, that means 2 over n cubed minus 0 is less than 1 over 10 to the 6. Well, that's going to be 2n because there's 0, and the absolute value of 2n cubed is going to be 2n cubed. So that means that I need to solve 2 over n cubed is less than or equal to 1 over 10 to the 6. Oh, and actually, I want to find this capital N, so I'm going to make this here. So what I'm going to do here is solve 2 over n cubed is less than 1 over 10 to the 6. That's going to give me this point n, such that whenever my little n is bigger than n, that's going to happen. So this is going to be the dividing line where this happens. So I solve this, multiply both sides by capital N cubed, 10 to the 6. Those cancel, so I get 2 times 10 to the 6. This cancels, so I get is less than n cubed. So in other words, 2 times 10 to the 6 is less than n. Now I use my calculator, and that tells me I get something like that. Oh, let me look at the calculator real quickly. And I get 125.6 is less than n. Again, n must be a whole number according to the sequence, so I'm going to say let n be 126. Okay. So what I claim, that is if n is greater than n equals 126, 2 over n cubed is going to be less than 1 over 10 to the 6. Okay, so here I'm going to start with n, little n equaling capital N, so 126. So I get 2 over 126 cubed. Now I'm going to get my calculator and copy that. So I get 2 divided by 126 cubed. Oops, my mistake here. And let me try that again. Sorry, my calculator is messing up. Actually, I'm messing up my calculator, more likely. So I do that, and I get this is equal to 9.998 times 10 to the minus 7. That's going to be less than 10 to the minus 6. Yes. Okay, so when n is equal to 126, I'm a little bit less than that. So I'm going to pick a different n. I'm going to pick an n equals 200. And I'm going to look at 2 over 200 cubed. And I claim I'm going to get a number less than 1 over 10 to the 6. So we'll test that out. 2 divided by 200, quantity cubed. And what I get here, surprisingly, it's not as big as you'd think, but this is about 2.5 times 10 to the minus 7. Again, that's less than 10 to the minus 6. We'll do so. Basically, what I'm doing is I'm claiming that whenever my index is bigger than 126, this term is going to be less than my epsilon. And I just did a couple of test values to convince you that it's true. So we'll do one more. We'll do n equals 500. And I'm going to be pushing the limit of my calculator, I think. See what we get there. 2 divided by 500, quantity cubed. And I get this is equal to 1.6 times 10 to the minus 8. And again, 10 to the minus 6. Bottom line, whenever my little n is bigger than this thing is going to be very, very close to my limit L. That's all that's being said here. I hope this makes some sense. But again, don't worry about it if it doesn't. We can come back to it.